The quest for finding life beyond Earth is one of the most fascinating and ambitious endeavors of modern science. The discovery of thousands of exoplanets, planets orbiting other stars, in the past 3 decades has opened up new possibilities and perspectives for the existence of alien life forms. However, detecting and characterizing these distant worlds is not an easy task and requires the use of sophisticated techniques and instruments. Moreover, identifying and interpreting the signs of life, or biosignatures, in the atmospheres of exoplanets is a complex and challenging problem involving many uncertainties and assumptions. But before we get into it, make sure you hit the like button and subscribe to my channel if you haven't already. And if you want to get notified every time I upload a new video, click the bell icon as well. It really helps me out and I appreciate it a lot. Alright, let's get started. Biosignatures are the chemical or physical indicators of the presence or activity of life on a planet. Biosignatures can be produced by living organisms directly, such as the emission of gases or the formation of structures, or indirectly, such as the alteration of the environment or the interaction with other molecules. Biosignatures can be detected by observing the spectra of the light that is reflected or transmitted by the planet's atmosphere or surface, and looking for specific absorption or emission features that correspond to certain molecules or elements. For example, oxygen is considered a potential biosignature because it can be produced by photosynthesis, the process by which plants and algae use light to convert water and carbon dioxide into organic matter and release oxygen as a byproduct. Oxygen can also produce ozone, a molecule composed of 3 oxygen atoms, which can be detected by its characteristic absorption of ultraviolet and infrared light. However, detecting biosignatures is not a straightforward or conclusive process and requires careful analysis and interpretation. Biosignatures can be affected by many factors, such as the properties and evolution of the star, the planet, and the moon system, the composition and dynamics of the atmosphere and the surface, the presence and distribution of clouds and dust, and the interference of other sources of light, such as other planets or stars. Biosignatures can also be produced by non-biological processes, such as the photolysis of water by ultraviolet radiation, or the oxidation of minerals by volcanic gases, which can create false positives or mimic the effects of life. Conversely, biosignatures can also be hidden or destroyed by other processes, such as the consumption or reaction of gases by other organisms or substances, or the escape or depletion of molecules from the atmosphere, which can create false negatives or mask the presence of life. Therefore, biosignatures need to be evaluated and validated by multiple lines of evidence, and by considering the context and the plausibility of the scenarios and the mechanisms involved. The JWST is a space telescope that will be launched in October 2023 and will orbit around the Sun at a distance of about 1.5 million kilometers from Earth. The JWST will have a primary mirror of 6.5 meters in diameter and will operate in the infrared range of the electromagnetic spectrum from 0.6 to 28 micrometers. The JWST will have 4 scientific instruments: a near-infrared camera, a near-infrared spectrograph, a mid-infrared instrument, and a near-infrared imager and slitless spectrograph. The JWST will have several scientific objectives, such as studying the formation and evolution of galaxies, stars, and planets, and investigating the physical and chemical properties of the interstellar and circumstellar medium. One of the main goals of the JWST is to observe the atmospheres of exoplanets and to search for biosignatures. The JWST will use a technique called transit spectroscopy, which measures the amount of starlight that is absorbed by the planet's atmosphere as it passes in front of its star. The The JWST will be able to observe the spectra of several exoplanets, ranging from gas giants to rocky worlds, and to detect and identify various molecules and elements, such as water, carbon dioxide, methane, ammonia, oxygen, ozone, and iron. The JWST will also be able to measure the temperature, pressure, and cloud cover of the exoplanet atmospheres and to infer their structure and dynamics. The JWST will be able to observe some of the most promising candidates for hosting life, such as the 7 Earth-sized planets of the TRAPPIST-1 system, which orbit a red dwarf star at a distance of about 40 light-years from Earth and which have the potential to have liquid water on their surfaces. Imagine a moment that could redefine our understanding of existence, a moment where we find life beyond Earth. The quest for extraterrestrial life isn't just a scientific expedition, it's a journey that shakes the very core of our understanding about who we are in the grand tapestry of the cosmos. This search doesn't merely aim to find microbial life on a distant exoplanet. It seeks to answer age-old questions that have intrigued philosophers, scientists, and thinkers for centuries. What is the origin of life? Are we unique in this vast universe? But the journey doesn't stop at existential questions. It dives deep into the realm of biological diversity and complexity. Imagine discovering a form of life so different from ours that it defies our conventional definitions. What if life exists in the methane lakes of Titan or the icy oceans of Europa? The possibilities are endless, and each discovery would be a testament to the incredible tapestry of life forms that could exist in the universe. The search for life beyond Earth also serves as a mirror reflecting our own biases, ethical dilemmas, and the very essence of our human condition. It challenges us to confront our preconceived notions about what life should be and forces us to reevaluate our ethical responsibilities. Should we interact with newfound life? What protocols should be in place to protect these alien ecosystems? These are questions that compel us to look inward even as we gaze outward into the cosmos. This monumental task isn't a solo endeavor. It requires a symphony of international cooperation, cutting-edge technology, and a shared set of ethical guidelines. The James Webb Space Telescope, JWST, may be a giant leap in this quest, but it's just one piece of a much larger puzzle. The search for extraterrestrial life is a collective endeavor requiring the wisdom of astronomers, biologists, ethicists, and even policymakers. It's a testament to what humanity can achieve when we unite in pursuit of a common goal. Patience and perseverance are the unsung heroes of this cosmic journey. The search for life is not a sprint, but a marathon, one that will span multiple generations and perhaps even epochs. It's a quest that demands the humility to accept that we may not find the answers in our lifetime, yet the courage to continue the search. It's a journey that invites us to be part of something much larger than ourselves, a journey that is as rewarding as it is challenging, and one that promises to captivate our imagination for generations to come. So, as we stand on the precipice of potentially life-altering discoveries, let's embrace the journey. After all, the quest for life beyond Earth is more than a scientific endeavor. It's a journey of discovery that has the power to unite us all in awe and wonder. If you like what I do in here, don't forget to hit the like button and subscribe if you haven't already. Also, if you have some anime that you'd like me to cover, write it down in the comment section. Thanks for watching, and I'll see you on the next one.